Assalamualaikum warahmatullahi wabarakatuh. Hai guys, perkenalkan nama saya Kholif meilani dengan NPM 2101008. Di sini saya akan meringsen sebuah video. Ini dari channel luar negeri guys. Video ini membahas tentang ilmu komputer. Jadi untuk teman-teman yang sedang belajar komputer atau ingin menguasai ilmu komputer, nah video ini cocok dengan kalian. Oke guys, langsung saja kita bahas videonya. Di video ini dengan channel Mind of Science dengan judul Map of Science. Maksud dari channel dan videonya membahas tentang ilmu komputer. Di awal kita dikenalkan kita membuat komputer untuk mengembangkan otak kita. Awalnya ilmuwan membuat komputer untuk perhitungan aritmatika. Tapi ternyata komputer juga sangat berguna untuk hal lain, menjalankan seluruh internet.
Incredibly useful for many other things as well. Running the entire internet, lifelike graphics.
Grafik yang terlihat darinya seperti nyata, otak buatan atau mensimulasikan alam semesta.
Artificial brains or simulating the universe. But amazingly, all of it boils down to just flipping zeros and ones. Computers have become smaller and more powerful at an incredible rate. There's more computing power in your cell phone than there was in the entire world in the mid-1960s. And the entire Apollo moon landing could have been run on a couple of Nintendos. Computer science is a subject that studies.
Ilmu komputer adalah bidang yang mempelajari apa saja yang dapat dilakukan oleh komputer.
Is what computers can do. It's a diverse and overlapping field.
Bidang ini sangat beraneka rupa dan tumpang tindih, tapi saya akan membagi menjadi 3 bagian.
But I'm going to split it into 3 parts. The fundamental theory.
Teori dasar ilmu komputer, rekayasa komputer, dan terapannya.
Computer science, computer engineering, and applications. We'll start with the father of theory.
Kita mulai dengan pelopor teori ilmu komputer, Alan Turing, yang merumuskan konsep mesin Turing.
Computer science, Alan Turing, who formalized the concept of a Turing machine, which is a simple description of a general-purpose computer. People came up with other designs for computing machines, but they're all equivalent to a Turing machine, which makes it the foundation of computer science. A Turing machine contains several parts. An infinitely long tape that's split into cells containing symbols. There's also a head that can read and write symbols to the tape. A state register that stores the state of the head, and a list of possible instructions. In today's computers, the tape is like the working memory or RAM. The head is the central processing unit, and the list of instructions is held in the computer's memory.
And a list of possible instructions. In today's computers, the tape is like the working memory or RAM. The head is the central processing unit, and the list of instructions is held in the computer's memory. Even though a Turing machine is a simple set of rules, it's incredibly powerful, and this is essentially what all computers do nowadays. Although our computers obviously have a few more parts, like permanent storage and all the other components. Every problem that's computable by a Turing machine is computable using lambda calculus, which is the basis of research. Computable by a Turing machine is computable using lambda calculus, which is the basis of research in programming languages. Computability theory attempts to classify what is and isn't computable. There are some problems that, due to their very nature, can never be solved by a computer. A famous example is the halting problem, where you try and predict whether a program will stop running or carry on forever. There are programs where this is impossible to answer by a computer or a human. Many problems are theoretically solvable, but in practice take too much memory or more steps than the lifetime of the universe to solve, and computational complexity attempts to categorize these problems according to how they scale. There are many different classes of complexity and many classes of problem that fall into each type. There are a lot of real-world problems that fall into these impossible to solve categories, but fortunately computer scientists have a bunch of sneaky tricks where you can fudge things and get pretty good answers, but you'll never know if they're the best answer. An algorithm is a set of instructions independent of the hardware or programming language, designed to solve a particular problem. It's kind of like a recipe of how to build a program, and a lot of work is put into developing algorithms to get the best out of computers. Different algorithms can get to the same final result, like sorting a random set of numbers into order, but some algorithms are much more efficient than others. This is studied in algorithmic complexity. Information theory studies the properties of information and how it can be measured, stored, and communicated. One application of this is how well you can compress data, making it take up less memory while preserving all or most of the information. But there are lots of other applications. Related to information theory is coding theory. And cryptography is obviously very important for keeping information sent over the internet secret. There are many different encryption schemes which scramble data and usually rely on some very complex mathematical problem to keep the information locked up. These are the main branches of theoretical computer science, although there are many more that I didn't have time to go into. Like logic, graph theory, computational geometry, automata theory, quantum computation, parallel programming, formal methods, and data structures. But let's move on to computer engineering. Designing computers is a challenge because they have to do so many different things. Designers need to try and make sure that they're capable of solving many different kinds of problems as optimally as possible. Every single task that runs on a computer goes through the core of the computer, the CPU. When you're doing lots of different things at the same time, the CPU needs to switch back and forth between these jobs to make sure everything gets done in a reasonable time. This is controlled by a scheduler, which chooses what to do and when and tries to get through the tasks in the most efficient way, which can be a very difficult problem. Multiprocessing helps speed things up because the CPU has several cores that can execute multiple jobs in parallel, but this makes the job of the scheduler even more complex. Computer architecture is how a processor is designed to perform tasks, and different architectures are good at different things. CPUs are general purpose, GPUs are optimized for graphics, and FPGAs can be programmed to be very fast at a very narrow range of tasks. On top of the raw hardware, there are many layers of software written by programmers using many different programming languages. A programming language is how Humans tell a computer what to do, and they vary greatly depending on the job at hand, from low-level languages like assembly through to high-level languages like Python or JavaScript for coding websites and apps. In general, the closer a language is to the hardware, the more difficult it is for humans to use. At all stages of this hierarchy, the code that programmers write needs to be turned into raw CPU instructions, and this is done by one or several programs called compilers. Designing programming languages and compilers is a big deal because they are the tool that software engineers use to make everything. So they need to be as easy to use as possible, but also versatile enough to
Oke, Jadi intinya dari video ini menjelaskan tentang awal mula dari komputer sampai dengan saat ini. Dari awalnya penciptanya alat turun itu sampai saat ini robotik yang mirip dengan manusia. Kecerdasan buatan yang dibuat seperti manusia. Intinya, kita makin kesini harus semakin teliti dan semakin cermat dan jangan sampai ketinggalan teknologi. Keuntungannya sangat besar. Kita disinggung di bagian ini. Di sini kita disinggung sangat besar kepada manusia dan akan menarik untuk melihat kemana teknologi akan berkembang. Lanjut. Dalam 100 tahun ke depan, siapa tahu mungkin suatu hari nanti kita semua akan menjadi komputer. Oke, dari itu kita harus lebih pandai untuk membuat program dan sebuah masalah. Oke guys, cukup sampai di sini pertemuan kita kali ini. Sampai jumpa lain waktu. Assalamualaikum warahmatullahi wabarakatuh.